r minus ra modulus cubed modulus cubed, and this now tends to r goes to ra. Now how can we make sense of this? Now how could we proceed ahead? We could write we could take two limits, to one left hand and one right hand, and then we would say r equals to ra plus epsilon for epsilon greater than 0 and epsilon equal to 0, and r is equals to ra minus epsilon for epsilon equal to 0, epsilon positive. So we have these two things, and when we do these two things, okay, so I put in these two equations. So I put first equation, what I get is r minus ra is epsilon by epsilon cube. So I get it is e square times epsilon by epsilon cube by modulus of epsilon cube, and this, and plus what I get here is r minus ra is minus is plus ea square. Okay, so here it is ea square minus epsilon by epsilon cube. So you have these two things. Now what would I like to do? Well, when you get two values over here, let's average these values, and so you have modulus, or have half ea square divided by epsilon minus epsilon cubed minus epsilon cubed, and which is equal to 0. So you can see that the average is 0, and the value of that term is 0. So there is no self contribution. Well, you could take limits from all the sides, but here only taking two limits were sufficient. Two-sided limits were sufficient. So that was for today. That was the first lecture, and let me know if you have any doubts in these things. Well, this is only the first lecture, so it's quite elementary, and I urge you to practice this derivation once. I urge you to practice this derivation of how I got the gradient with respect to a of 1 by r minus ra is equal to minus of r minus ra divided by modulus of r minus ra whole cube. How did I get it? You just practice the derivation once. This is something very elementary, so I urge you to practice the derivation once as an exercise, because you will be encountering more of these things in future. So let yourself be convinced about that one first. And in the next lecture we'll be talking about something that is more far ahead now, about Gauss's divergence theorem, Gauss divergence theorem, and things like that. And we'll be deriving the divergence of the electric field and some basic stuff. So that's all from my side today. Okay, thank you.